In the previous part, we have drawn the free body diagram and we have calculated the values of unknown reactions. Now, here we will see how to calculate the values of shear along the beam length and how to draw the shear force diagram. Let's name all these points. This is C, D and E. Now let's see the sign convention. At the left of the section, upward force is considered positive, downward force is considered negative. And at the right of the section, we have downward force as positive and upward force as negative. If you are okay with this sign concept, it is well and good, or otherwise you can refer my video on a simple technique to determine the sign for shear force and bending moments. Let's start with the point A. Here, to find the shear at A, consider a section just near A. At the left of the section we have one force and at the right we have three forces. So better to consider left of the section. So there is only one upward force and at the left of the section upward force gives positive shear. So we can write at A shear is 8 kilonewton. From A to C there is no other force. So from this point to till this point the shear force will be the same. So we can write at C left side it will be 8 kilonewton. Okay, once we cross this point load at C, there will be a change in shear force. We can take a section here. Here is an upward force of 8 kilonewton and there is a downward force of 4 kilonewton. This will be positive and this will be negative. 8 minus 4 will get 4 kilonewton. So at C we will have 8 kilonewton. From that point there will be a sudden drop to 4 kilonewton. Now from C to D there is no other force. So till point D shear will be the same. We can write it will be 4 kilonewton. So from D to E we have a UDL. Your shear force variation will be linear. At D we know what is the shear force and at the end point E we need to calculate the shear force and we can show the linear variation from D to E. Now let's calculate at E. So for calculating shear at E we can consider right of the section because there is only one force and here we have three forces. So better to consider this side. So at E we have downward force of 2 kilonewton at the right of the section. So we will get a positive shear of 2 kilonewton. Now what is left is point B. For calculating the shear at B we can consider a section here and at the right of the section we have a downward force of 2 kilonewton. So we will get a positive shear of 2 kilonewton. So now it's the time to draw the shear force diagram. So this is the beam line. I have taken all these points down. I have marked the calculated shear. At A we have 8 kilonewton and at C we have 8 and 4 and again at D we have 4 kilonewton. At E and B we have 2 kilonewton. See here from A to C there is no other force acting. So once we mark the shear at A, it will be constant till the point C. So we will get a straight line for this portion. Now there is a point load here and the shear at C is 4. So there will be a sudden drop to 4. From C to D there is no other loads. From here again it will be constant. And here from D to E we have a linear variation, and at D we have 4 and at E we have 2. So there will be a linear variation. And from E to B there is no other force, so it will be a constant. So this is our shear force diagram. Hope it's clear till now. In the next part we will see how to calculate the bending moment along the beam length and how to draw the bending moment diagram.